Today I want to talk about circuit conditions, and this is sometimes a confusing subject. So we're going to look at using some basic schematics. We're going to figure out an open circuit, a closed circuit, a short circuit, unwanted high resistance in a circuit, and a ground fault. So let's start with just a basic circuit, and we're going to put a light bulb in here and a resistor to make sure that it's getting the right amount of power. There's our light bulb. Now, if I was to put a switch in here, that circuit is open at the moment. Now, we can close the switch simple enough and create a closed circuit. So we want a closed circuit. Closed circuits are when things are working. You often hear of CCTV or closed circuit TV. That means that it has a wire going to a computer and they can see what's going on. So it's a closed circuit. Open circuits are when we open the switch. Now every circuit will have a fuse. If something happens in that circuit, let's say a conductor comes down and touches right here and causes an extra load, that may blow that fuse depending on what the fuse was rated for. When the fuse blows, we have an open circuit. So in order to keep electricity flowing, we need closed circuit. Open circuits are a result of turning off the circuit by opening a switch or a break somewhere in the circuit. The battery connection breaks off. That would create an open circuit. You'll repair that battery connection and now you have a closed circuit. So a short, and essentially when I wrote this, I'm going to put another circuit right here with another light bulb, and it's going to go off to ground. And we'll put a switch in there that's closed. So we'll go down to the battery, and that one goes to ground. So what's going to happen in a short circuit, let's say a wire crosses over here, and power is able to flow here. When you close this circuit, this light bulb will illuminate, but this light bulb will illuminate as well. And that wasn't intentional. That's as a result of a wire crossing. Something is touched, something's rubbed through, a conductor is touching, and now we have a short circuit because it's shorted something else. This also happens in a coil of wire. A lot of times we have an iron core and we wrap wire around it. Plus, minus. We send it to a battery which makes a really effective electromagnet. So this electromagnet may draw 2 amps and become a very good electromagnet. Now what happens sometimes, and you've probably seen these iron cores, they're wrapped really finely and they have varnish on this wire and it rubs eventually. And when they touch, they short out. So essentially this wire here could touch that wire there. Now, there's less resistance in this circuit, which means the amperage is going to go up. So it may go up to 5, but it is no longer a good electromagnet because we're not using all the amperage going through that wire, creating a good electromagnetic field in the wire. So the amperage goes up, the electromagnet is no longer any good, so it doesn't work and we're drawing. That's a short. Unwanted high resistance. Batteries, and we've seen that, batteries will get that green fluffy stuff growing on there, which is copper sulfate, and it will cause resistance between the battery connection and the battery. So that resistance is an unwanted high resistance. So now, if we were to measure voltage drops, we would find that there's higher resistance in this circuit because we've grown these unwanted high resistances. Typically, we'll see them on a truck outside. The truck will see the connections. There may be a plug here, and it will go green, and the connection will become high resistance, and the light bulb will go dimmer because there's more resistance in the circuit, so the amperage is dropped, and those are things we have to clean up. And finally, the last one, not unlike a short circuit, a conductor goes to ground. If a conductor goes to ground, let's just put it on the other side here. If a conductor here goes to ground, all the battery source will try to go through that conductor and it will blow the fuse. because there's too much amperage. We put the resistor in there originally to reduce the amperage for this circuit, for this light bulb, and now we've added a ground, and the battery is trying to unload through that ground short before the resistor, and it's going to create high amperage in this circuit, and the fuse is going to blow. That is a ground fault. And traditionally, if you throw another fuse in there, you would find that it blows out right away, and you would understand we have a ground fault. Often short circuits are confused with ground faults, because if the short that's supplying this load is large enough, it can blow the fuse as well. But you will find lights go on here. Typically on a short, you will have this light come on and that light come on. Somewhere else, the power is coming in. A ground fault, always, when it goes to ground, blows the circuit. So that's a ground fault.